So thank you everyone for joining. It is my great pleasure today to talk to you a little bit about Zeek 7 and our upcoming work sort of beyond that release. I think the presentation was titled as a roadmap update. I'm gonna do that as well, but I'm gonna spend a little bit of time to talk about Zeek 7 in particular since we just released it. So without going into too much detail, I just wanted to make sure to thank everybody who contributed to this release. This was quite a major effort on our part. We started work, I think, all the way back in February, so around 5 months, 1,100 commits, 330 pull requests, and about 140 closed issues, if my reporting script is correct. And I'm not going to name everybody on this list here, but as usual, a huge shout out to the dev team, to the folks in our testing subgroup who basically kicked the tires on our release candidates, and then the various people in our community who contributed features and bug reports. So thank you all. We quite literally couldn't do this without you. I'm getting a message here about Jason raising a hand. Just wanted to mention that. Just going to continue a little bit here. So I have in the past, made sure to give you sort of an overview of our release cadence. And I think I'm going to do this one more time here in this presentation. And then in the future, we'll probably just sort of refer back to that because it's really not sort of changing very much. But for Zeek 7 in particular, since it's sort of a major release, I wanted to do this one more time to basically make sure that people understand where it fits into our sort of greater scheme of things and why it matters in particular. So as you might well know, so we do about 3 feature releases per year, sort of a .0, .1, and .2 release. And the .0 release is what we call our long-term support release. So that release gets updates for at least the upcoming year. And if you want to basically prioritize stability in your deployments, then this is the version you should choose over others. So what happens after we have released our initial version of that LTS release is that we might find bugs and issues and updates, and that will lead to a point release, like an X.0.1 release that continues sort of and comes out as the need arises. And then about a third of a year later, when we think it's time for our first feature release following the LTS release, we release the .1, and that release is significant for 2 reasons. First, it is our deprecation removal release. So anything that we've deprecated over the prior LTS cycle and year is going to get removed there that really actually sort of bugs us in that release. Things that are no longer relevant, that have been superseded by newer code, newer APIs, and so forth. So if you switch to that release because you are basically like more eager to be on the cutting edge, then this is something to keep in mind because basically the potential for surprises is somewhat larger in that release than in the other ones. And second, this is also the end of our support window for the previous cycle's LTS release. So what is X.0 here as the current LTS release has a preceding LTS release in basically cycle X-1. And when X.1, as I'm showing here, is released, then we stop supporting the previous cycle's LTS release. So you basically have about a year plus 1 release window to update, which we think is pretty good, even though people sometimes tell us that a longer LTS time window would be appreciated, and we understand that and might revisit that at some point. But this is sort of a balance between sort of available resources and being able to offer long-term support release at all. And then development continues, and we might find bugs and so forth in that release. We make a point release for that one, and then we backport those fixes as we see fit or as is required to the LTS version and make a new patch release for that LTS line of releases. And then in the meantime, development continues. About another sort of third of the year later, we will release a .2 version, and the same model applies there. This is basically going to include sort of the newest features that we have been working on at the time. And as before, like if bugs and additional fixes sort of come in, then we will make patch releases there and backport as needed into the LTS cycle. And after about another third of a year, this will again lead to the next cycle and basically the beginning of the next LTS release. So to give you an idea, I think given that I've been talking about 7.0, I think you probably understand where we are in this right now, but we basically just wrapped up the 6.0, 6.1, 6.2 cycle, just released 7.0 a couple of weeks ago. And so we're now just at the beginning of the new 7 cycle and have a new LTS released out. So introducing Zeek 7. So I'm just going to cover what's in this release to the extent I can in this presentation. This will by necessity omit a bunch of stuff, but I'm going to focus on the biggies, and I'm hoping I can do that justice in the time available. So we have 3 particular biggies that arrived in 7.0 and were not in prior releases, and the bottom 2/3 of the slide basically cover stuff that you will already have benefited from if you're running 6.2 or 6.1. So the first biggie in 7.0 is a new telemetry framework. I'm going to go into detail about that in a short while. This is basically to address several deficiencies that we thought were present in the way the current framework works. And again, I'll cover that in a second. The second biggie is that our script optimization engine, ZAM, the Zeek abstract machine, is going mainstream. So this is a feature that has been in Zeek for a while, and that some of you, particularly the folks who are more technically sort of familiar with Zeek, may have already explored, but it is basically now reaching a stage where we think it is ready for people to try it more broadly. And the third biggie is that Zeek 7 is powered by Spicy 1.11, which is a new release that just came out prior to Zeek 7, which features essentially better code generation and a bunch of performance improvements. And then from the last cycle, from 6.1 and 6.2, there is a bunch of stuff that you should be excited about. One is that Zeek is just generally faster now. If you are following our blog, you will have seen this in the recent past as well. Arne put together a really nice blog post about that. And it particularly comes out if you run Zeek in bear mode, because some of the, or many of the optimizations and fixes and sort of just improvements across the board are in the core in certain places that matter most if you're not doing a heavy scripting workload. But it doesn't really matter. Like, you should simply sort of like deploy 7 and see what it does for you, and you will hopefully see it sort of be like up to sort of a 2-digit percentage range more performant, which is really nice. We have a bunch of new analyzers for you guys. There is a new LDEP and Quick analyzer. They're both powered by Spicy, which we're clearly sort of investing going forward for all of our new protocol parsers. There's a built-out ability to handle HTTP upgrades properly and look into WebSockets, because we learned from community members that there is a certain set of use cases where you do actually have HTTP visibility, and where that ability to look into WebSockets is pretty handy. And since we're still, to some extent, learning about Spicy and BinPack and how they sort of, perform in relationship to each other, this is one of the few cases where for a new parser, we've actually built out 2 implementations to be able to sort of learn and understand performance a little bit side by side. This is most likely transient, because clearly the future points at Spicy. So in the meantime, if you are sort of exploring these parsers and you have feedback for us in terms of Spicy and in particular Spicy's performance, then that is always really helpful for us to know. And I want to apologize for my voice, but it's just completely shredded today. I don't know what's going on. There's also a new packet analyzer. This is PPP, which has sort of been long overdue and landed during the previous cycle. And then several other parsers have seen a bunch of improvements. For SMB2, there is more correct parsing in place now. This actually technically also came in with the Zeek 7 release, not prior ones. For others, there's just been a lengthy sort of list of improvements. Some also community contributed. Thanks again for that. For SMTP, there's always been this issue that we don't handle, or did not handle their chunked sort of support properly. BDAT, that is now there. So for those of you who actually encounter that in that traffic, Zeek will no longer sort of stumble over that. There's a bunch of improvement to JSON handling. So this is mainly at the level of built-in functions that you can use to take a data structure in the script layer and write it out into JSON, and also do the opposite, take some JSON and map it back to a data structure in the script layer. And we've built that out to a point where you can now essentially reliably do round tripping. So whatever you write out into JSON, you should also be able to read back into it. In the past, it was a little bit more sort of, partial. There was a bigger feature in the 6 cycle called delayed log writes. And this is sort of niche, but for those of you who need it, it is gold. And it is basically the ability to tell Zeek to hold on a little longer to a log entry that is about to be written out and augment that record or that log write for a little bit of extra time. Which, depending on how you do, sort of the enrichment of these log entries, can prove really valuable. There's a nice feature in connection histories, which lots of people sort of rely on to basically sort of gauge the health of their monitoring, to understand sort of what is happening in a connection in the conlog, and it is the character X, and it's basically a realization that we came upon after a bunch of fuzzing finds for our protocol parsers, which is that oftentimes there are cases where you simply have to make decisions that are sort of thresholding certain analyses steps because otherwise you don't really know how deep you should look into something, or you cannot make a decision that is technically strictly right or wrong. You just have to sort of cut things off at some point. That was opaque in the past, and now in the connection history, when you see that letter, you can basically tell, like, yeah, okay, so we stopped parsing here because of one of those decisions, not necessarily because the activity on the wire implied that stop. It's one that we decided to do basically to keep Zeek healthy. And then there's a whole bunch of language features that I won't itemize sort of in detail, but one of the cuter ones is that if you have a table that is indexed by patterns, so by regular expressions, you can now take a string and basically index into that table, and it will efficiently parallelize the lookups for anything that matches the pattern, and return the list of things that fit that lookup. So this is sort of detailed, but it's another one of those things where, if you want that, this is exactly what you were hoping for. And there's a bunch of other stuff. It makes it easier to load scripts conditionally. It makes it easier to write correct code via an assert statement, and a bunch of other stuff. And I'm again glossing over a bunch of details here. And the biggie, as always, I think I've mentioned this many times in the past as well, is to please read the release notes. You can do this in a couple of ways. One is really just the releases themselves, as Tim puts them on GitHub, have their own release notes for a particular release. And if you want the full story, you can basically go to the news file straight up on GitHub. And it basically has the full history, like until the beginning of time, which in this case, I think, means Bro 2.0. If you want a slightly more detailed form of this, there is a file called changes that is almost at the level of git commits. This is pretty handy for searching for things, but if you feel like, I think there was something that I'm not quite finding in the release notes, you can go to that file, or if you're git capable, then you can just basically run that straight on your sources, of course, but this is sort of somewhat more accessible for people who aren't hooked up to Git. And it's worth pointing out that the same is also true for Spicy. Those two files exist in the Spicy source tree as well. So as Spicy matures, you can basically sort of go in there as well and understand the releases in great detail. All right. So as I was saying earlier, one of the 3 biggies in the new release is the new telemetry framework. And so a little bit more detail on that. So this is a first part of a major effort that is currently underway to revamp Broker. And I'll cover that more in the roadmap section coming up, but just keep in mind that this is basically one puzzle piece of a bigger revamping that we're doing here. And the main reason why we did this work is because we wanted telemetry and metrics to be powered fully by Zeek and not rely on an external component to provide this to us. And so far, this was Broker via CAF, its underpinning, because in the past, it was easy to rely on it because it conveniently already had really handy infrastructure for providing metrics. Now, this is a lot of work under the hood, but the good news is that for users, this actually more or less looks the same. So you will continue to be able to scrape telemetry via Prometheus, just as before. And if you're used to the script layer API for adding your own telemetry in your packages and so forth, that API is mostly unchanged. There are some little bits that we had to tweak a bit, but it's mostly otherwise sort of working the same. So it's our beta testers have basically told us that, yeah, indeed, the changes needed there are really very manageable. The bigger news is that we have changed the approach we're taking to metrics aggregation. And so if you are familiar with the history of this a little bit over the past several releases, you know that we sort of flip-flopped there a little bit about how we did that. So we had an initial take on always aggregating telemetry across the cluster in the manager. And that proved tricky for a couple of reasons. One was that it could easily, for larger clusters, prove quite expensive on the manager and therefore wasn't so great. So then we stepped away from that and just basically got it out of the way by turning it off by default, because not everybody needs telemetry that is aggregated across the whole cluster, and hoping essentially that for folks who run smaller clusters, turning it back on is just fine. What we've done this time is basically we've outsourced the thing altogether. So we're now relying on a feature in Prometheus that's called service discovery to let you scrape telemetry across the whole cluster. And basically what this does is just indirection at the HTTP level. So we have one endpoint in the cluster. This is the manager that you can point at a URL that ends in just services.json, and you will get this little JSON blob that looks a little bit like what I'm showing here. That is essentially showing you for each of the nodes in your cluster where you then need to go to scrape the telemetry for that node. And so what I'm showing here is a bit hypothetical because it's a small cluster with just 3 nodes. So in reality, this would be bigger, but the concept applies. And the biggie is that Prometheus does that for you. You don't need to do that. But if you point Prometheus at that URL, it will be able to do that and then go out to the remaining nodes and grab telemetry as always. This does require a new port on every node in the cluster. And we considered that fairly carefully because we've heard in the past that for people, it can be who run larger clusters and who are basically subject to, other external sort of constraints by their network administration, by their security policy. That is a concern. Like opening up ports is always a concern, but in this case, we felt that the benefits outweighed the concerns. If this is really a major issue for you, then please let us know, because we could theoretically add other mechanisms back in, but we're hoping that the convenience of this trumps the need to basically go back in and do it manually again. The new ports are supported out of the box for Zeek control and the management framework. So as long as you can get to them, you don't really need to do anything special. You can control the sequencing of the ports and where they start as just basically as with the broker ports themselves. Take a look at the documentation. It's all, I think, spelled out pretty nicely, and let us know how it goes. So the second one I mentioned earlier was ZAM, the Zeek abstract machine. So again, so ZAM is a optional script layer optimization engine. It's been in Zeek for quite a while, I think technically since 4.2. And I think many of you have explored it in the past. But we've, and particularly Vern, this is essentially Vern's brainchild from the get-go, has been working on that continuously. And we think it's now in a spot where it's basically a first-order sort of citizen in the Zeek ecosystem. And we're encouraging people to try it. The use is as simple as it gets. You basically just add this command line flag -O ZAM, and it kicks in. And the thing you need to keep in mind is that it basically changes the way the script layer is interpreted, which means that there is some upfront cost in how it compiles the to an AST so that it can then optimize its execution. And so depending on how you're running Zeek and how you're looking at performance, keep in mind that there is this startup sort of overhead that then gets compensated for at runtime. So if you do sort of a quick comparison just by sort of cranking a PCAP or some such, you need to keep this in mind because otherwise it can quickly look skewed. Since it's optimizing just the work that the script layer is doing, the payoff depends on how much work your Zeek installation really is doing in script interpretation. If it's more heavily spending cycles on log writes and so forth, then ZAM does not sort of weigh in as heavily. So from eyeballing performance so far and sort of trying it in a bunch of places, we've sort of learned that the benefit is usually sort of in the 10 to 15% range, but it will depend greatly on your installation. And we would love to hear from you if you turn this on, what you see in practice. make sure to read the documentation for this one, particularly over the upcoming releases, since I think we'll have to say more about it. And feel free to check out the command line options for it as well. There is a little bit more, but keep in mind that there is other than functionality, particularly around the idea of script compilation to native code that remains experimental for now. So we're not really sort of going near that for the public just yet, but sort of continuing to explore it under the hood. And then the third one, the third biggie in this release is Spicy 111. That has seen a ton of work by Benjamin and Robin. And essentially the biggies there are that the way it produces the AST and the parser code derived from your Spicy code is completely revamped. So the code generation is much faster, and the code that it generates is also more lightweight. This is basically, think of it as a V2 sort of based on lessons learned under the hood. And in our open parser development. It is useful for developers, particularly because when you're doing something wrong in your Spicy code, it is now much faster to sort of iterate quick, or much easier to iterate quickly on it, because you get those error messages much faster. It could take quite a while in the past before you finally got to that stage, and then it was just kind of tedious to iterate. And as a side effect, the parser has also gotten more correct. So if you had sort of little things in there that were technically not correct around, constants and some other things, then the parser might now bark at you. But that's a good thing, and essentially it should not be too much work to update your parsers to make them correct again. There's other stuff that matters, particularly in lossy scenarios. So, for example, if you have packet loss and Zeek feeds Spicy a partial sort of view on the data stream, which is that Spicy is now better at resynchronizing and giving you control over how you want to resynchronize to content in your parsers. There's better bit field support, which matters for some protocols. And in general, just keep in mind that compared to what you had in 6.0, if you're looking at this coming from the last LTS release, it is just much faster in general. And again, it's hard because it depends on details in your traffic, but ballpark up to like 30% is I think, we think, a realistic estimate. And this is also really nice. The documentation now features a best practices section that I'm linking to here. The slides will be available, by the way, of course, or just pull up the Spicy documentation. And this is largely based on lessons learned at Corelight with really large parsers, and we're quite grateful for that. So thank you guys very much. Okay, so the presentation was actually announced as a roadmap presentation. So here I go to talk a little bit about that. And I wanted to start by going into a little bit more detail about this broker revamp. So what I'm showing here, because I think this is one of those things that is easier in a diagram than in lots of text, is essentially the way Zeek works right now. So you have Zeek on top, and it rests on broker. Broker is just a library, but Zeek basically uses it for a surprisingly large amount of things. And there's lots of detail here, but essentially focus on 4 things. Broker provides a publish subscribe infrastructure and an API to Zeek. So there are topics that you can publish messages on. There are topics that you can subscribe to, and you will basically receive those messages that can be log writes, events, and so forth. There is a serialization, deserialization component in Broker that we rely on to send out things in the first place. And we actually technically do that twice. So up in Zeek, as essentially more or less as part of the event engine, or next to it, depending on how you sort of look at it, there's a first serialization, deserialization going on from Zeek's internal data types to Broker's data model, which it provides to users. So that's a first sort of translation step, and then Broker itself has backends for how it actually wants to serialize the data in its data model out onto the wire. And it currently has 2 of those. One is just its binary format that's been around since the get-go, which was basically the inception of Broker about a decade ago, and a JSON format that we added later on. This isn't really pluggable. It is basically just backend functionality that is designed as such in the code and provided as such. So if you wanted to add another, you would basically have to go in and patch Broker or add that to Broker. There's a third component that is basically anything around storage that is currently in Zeek's scripting layer. So if you've ever used, what we call broker-backed tables, or basically brokers get sort of a key val storage API, then that is directly powered by Broker. And there too, it has that functionality in there with a few backends, particularly two. One is SQLite and one is just this memory backend, so that you can basically store stuff in there, usually used for purposes of synchronizing across the cluster. And that's essentially it. So there too, this isn't really pluggable, but it is extensible should somebody want to add another backend. And then as a fourth one, there is the telemetry framework as it existed prior to Zeek 7, and it was essentially powered by an API fully resting in Broker, largely based on the fact that CAF, the C++ actor framework, which basically underpins a lot of stuff in Broker, has really good telemetry support. So at the time in the past, it was when we added telemetry in Zeek, it was natural to build on top of Broker just because it was very convenient. And so the biggie to take away looking at this image is basically just that Broker is in charge of a surprisingly large amount of stuff in Zeek at the moment, and it is essentially the only option for doing that in Zeek at the moment. And I'm sort of foreshadowing where we're going with this, which is sort of something along the lines of the following. So from the user's perspective, not much changes at all, because this is all sort of under the hood. But the event engine now can rely on pluggability in two components. One is publish subscribe. That doesn't go away. We need that for event and log write and so forth, publish subscribe for the foreseeable future. But the idea is that it becomes pluggable. So just like you can currently plug, log writers, IO sources, and so forth in Zeek, and as a independent sort of third-party component, we would like to get to a place where you can also do that with essentially the cluster backend, and Broker becoming just one of the possible options for this. And Arne has done some really nice and promising looking prototyping with a technology called Nats that some of you might be familiar, nats.io, which is just one instance of a message broker that is one of many available today, most of which didn't exist when we conceived Broker about, like I said, a decade ago. And serialization and deserialization, so like what we're sending, not how we're sending it, is sort of the same. So we would very much like that to become a first sort of order citizen in Zeek, not just something that we had to have implemented in one particular way. And so again, the way Broker does it could be one of those. The way you would do that in modern JSON that isn't essentially expressed in Broker's data model as the current JSON flavor, but just as you would expect it to be on a more higher level, we could then implement that as a plugin in Zeek. For script layer storage API work, it's the same story. Essentially, it'd be really nice if we're not essentially constrained by what Broker has implemented as backends, but if it were something that people can provide, just like they can provide, say, logwriter plugins right now. So you could store your stuff in SQLite, in Redis, in Memcache, whatever you have it, because these different backends can address particular use cases that we currently had to implement in the script layer very elegantly. So thinking, for example, of synchronizing content across the cluster, that is something that we implemented manually for data stores in the cluster framework. Some of you may know this, others maybe not, because for most people that never even sort of becomes a thing to be aware of. But if you, for example, run a centralized data store across your cluster, like just as a service, then you don't need to concern yourself with that, because by nature of being an independent sort of service that is available across the whole cluster, you gain that benefit sort of like for free. So we think there are three big things here that we would really like to see pluggable in the future that will allow us to do this really nicely. And the fourth component on the right here is just like what the telemetry framework is right now, mainly a fully self-contained functionality in Zeek. This is technically glossing over a small detail, which is that we are hooking Broker's current telemetry into the underlying Prometheus registry that runs in Zeek. So we haven't lost that telemetry. But that's sort of a detail. Conceptually, you can sort of think of telemetry now basically fully powered by Zeek and not depending on Broker in any way, shape, or form. And so this looks like Broker is sort of hugely diminished in the future, but that's not technically true. This is mainly sort of just an effect of how it's rendered in the diagram here. But it is keeping Broker, but making it an optional choice for your pub sub, and for serialization and deserialization in your cluster. And this is obviously a huge chunk of work and is keeping us quite busy, which is why I'm not going to make promises about what lands in which release. But this is underway right now, and we want to see this through because we think it'll really benefit Zeek going forward in terms of how you can diagnose clusters, how you can interact with clusters, how you can build third-party components into your clusters, and so forth. So this is pretty exciting. It's essentially done for telemetry. Tim is very much at it for storage right now. Arne is at it for the pluggable backends. And basically watch this space, like see how this continues to evolve over the next few releases. For storage, we're relatively certain that this will land in the 7.1, 7.2 timeframe. For the pluggable cluster backends, we will basically just have to see how it evolves. But if you're willing to run a very, very early prototype, there is a PR that Arne is iterating on that you can explore for this. So it's pretty exciting. Now is a good time to tell us if you're deep into certain message broker technologies, what you like to use, what you see benefits in, what you see downsides in, and so forth, because there's a ton of technical detail here that I don't have time to go into today, like whether a broker is a service or if it's point-to-point and so forth. There's a bunch to consider here that we're excited to look into. And then there's a bunch of other upcoming work. Of course, I have not tried to break this down sort of by topic area this time, because I'm not sure it's really much of a benefit here, but I'm just going to sort of sketch these real quick. So Spicy continues to mature and become more important for us. We'll continue to do performance improvement work. Benjamin is currently working on basically a optimization engine for the generated code. And as we learn about what people are doing with it, that goes straight into, you know, how we prioritize performance improvements and so forth, and where we do that work. We have a nearly ready TLS parser that Johanna has been working on for quite a while that I think I've also mentioned in the past, that almost made it for Zeek 7. But since it is essentially, you know, it's sort of a beta of a very important analyzer, we decided to postpone that a little bit and put it in place with 7.1, but not the earlier releases. And I think I've sketched this in the past as well, but it is pretty exciting because we're basically aiming for exact feature parity with the current binpack parser, which is pretty challenging. I'm actually impressed that we can sort of do that at all, but it's looking promising. And then the biggie is going to be performance and how we enable that transition. And what we're envisioning, but haven't really finalized, is that in a first version, you can optionally switch to the spicy one and gain experience that way. And then we'll probably in future releases switch the default over and eventually retire the binpack one. ZKG has bumped in priority because we're simply aware of the fact that it is getting a little rusty, and there is a certain set of use cases where it's just not very good right now. And this particularly concerns development. And of course, we want people who write Zeek packages to be, you know, well supported with our tooling. And if you've written Zeek packages in the past, then you know that ZKG is very picky about, you know, using Git and what you have checked in there, and is not so good about showing you easily what goes wrong when a test case fails or when you build a package, is underpinning like plugin code and so forth. So we're going to make a bit of a push on that front over the next, again, sort of 1 to 2 releases, because I think we think it is essentially overdue, and it's sort of just been on the sideline for a couple of releases, and it's showing a little. There's renewed interest from the community to be able to augment Zeek logs across the board more flexibly than you can currently do that. And this is a feature that is somewhat buried, though documented, in the logging framework that we call extension logs, or log extensions the other way around, sort of via a callback mechanism. And the way that currently works is very rigid. You can basically tuck on one particular sort of record to all of your logs without any context about what is the log or a log entry that is currently being written. And for some applications, it would be really nice to have some of that content. So we're going to log into how we can make that a little better. The JavaScript push. So that was, of course, the biggie in the 6.x cycle. And we're grateful to anyone who's kicked the tires on this and built the first sort of packages with it. And we've learned some lessons from that. There's been some feedback about what works well, how it's cool, what it's good for, particularly along the lines of integrating with other sort of infrastructure out there. But there's also some stuff where we're not, as good as can be right now. For example, it is still a necessity that when you build a Zeek package that involves JavaScript, that there needs to be a little bit of Zeek scripting in there to basically glue it all together, which is something that we could make a little smoother. And there are other sort of usage improvements around JavaScript as well that we could improve. But this is and remains an area where we're really keen for feedback. And the more cool stuff people build with this, the more we'll build that out further over the next few releases. And then there were, I want to admit this, there were several things that slipped in the 6.x cycle just because other things were more important, or we simply didn't end up having the time. One is log schema tooling. I've mentioned this too several times in the past. We would like to be able to show you with every release that comes out what the logs that Zeek produces by default look like, so that you can basically make a comparison to a past release and say like, oh yeah, okay, so I need to be aware of the fact that in log such and such, in the con log, there is now a difference in a certain field. Maybe there's a new field, maybe there's a whole new log altogether, and so forth. And you currently sort of have to read the tea leaves about that from the release notes, which isn't very nice. So we want to make that a little bit more tooling oriented. And then, of course, the management framework that has been sitting on my plate for a long time now, and I basically haven't been able to work as much on over the 6.x cycle as I would have liked, has a very clear list of sort of future steps that I just like to get back to. Hopefully, we'll be able to do that over the 7 cycle. And then there's more on that. I want to give a shout out to the folks who have been testing that at this point, particularly Mike Doppheide at ESNet. Thank you very much for all your feedback. This has been hugely helpful for us. And then there's some stuff that we've basically just pushed back for now, essentially due to the broker work, because it means that some stuff should settle before we come back to it. One is this newer sort of JSON serialization format. So if you've seen the current JSON format that is implied by broker, then depending on your expectations, you might have been a little bit surprised, because it is essentially not quite looking as you would expect it if you just come upon, a Zeek event and how you would render that in JSON. And that is because it is expressed in broker's data model. So we want to provide something a little bit more accessible, but that should now land basically as part of this push to revamp serialization in a pluggable form more broadly. So we've pushed that back a little bit. And this is also true for the new Python sort of quote bindings for WebSocket transport, where we will probably keep things fairly unchanged and continue to rely on broker for the time being. But so if you've built a sort of third-party component that you're hooking into your Zeek cluster, don't be nervous, because I think that will keep working for the foreseeable future. But those independent bindings we basically haven't had time for, and had to push back a little bit for that. All right, so I think that was a bit of a whirlwind tour through the whole thing, and I think that's all I had. I want to thank you all for listening. I apologize again for the state of my voice today. Sometimes I just have that. And here are the usual pointers: the official documentation, the GitHub links, the repository, and the project wiki. And if you want to get in touch with us, please do. The usual ways are our Slack and our Discord, our community URLs. You can find those easily on our project website or by just pinging us directly. And with that, I'm done. Thank you, guys.
Thank you, Christian, for the great presentation. And are there any questions for our speaker for today? Okay, I do not see any questions in the Q&A, and I'll just give a couple more minutes for people who would like to ask questions.
There was a raised hand a couple of times earlier that I had on my screen. So I apologize. I did not see that in real time, what that might have been about. So now would be a great time to cover that. Unless it was a technical problem with the presentation, now it would be a little late.
That was a technical problem on the user end, so it got answered. So Johanna took care of it. We do
good. Thank you very much.
Sure thing. We do have one question from Tim Larson. And he's asking for the stability of Zeek agent v2.
Oh, interesting. Okay. I did not mention that at all because we mostly consider it sort of a not, we have a fancy name for it that I'm sort of forgetting right now, but not a core component of Zeek. I think essentially stable as a V2 and looking for use cases. So Robin has put a bunch of work into that relatively recently, essentially in the form of this V2. And you should be able to deploy it, hook into Zeek, communicate events, learn host-based information as before. And if you're considering doing that or are doing that in practice, we would love to hear from you, because this is sort of a bigger topic that's been sitting there for a very long time. And it's depending on how plugged in you are to the whole sort of, I usually call this sort of the pendulum of security, cybersecurity, like how people go from like, now you need the endpoint, now you need the network. This is basically our take of saying like, you can just have both. And have it all handled in Zeek scripting as a distributed event-based system. So this has always been there for sort of the more adventurous users. And if you are deploying that, particularly at scale, we would love to talk to you. This would be super useful for us.
Awesome. Thanks, Christian. One quick note that if people would want to talk or speak, just like comments, feedback, or questions, just raise your hand and I would be able to allow you to talk. So if people do not want to type in the whole big question or like whole big comment or feedback, then that is another option. Just wanted to let everyone know about that.
That'd be great. Speak up, people, please. Or just DM me or us.
Yeah, that would be another way of reaching us. So just give a few more minutes to people who would still like to ask or talk. All right, I do not see any further questions or raised hands, so I think we can just wrap it up, this webinar. So thank you, Christian, again, for the amazing presentation and being our speaker for the first webinar. So thanks again. And thank you all for attending our first webinar in the series. A quick announcement before we adjourn for today is our next webinar is going to be on 18th September, exactly same time, 10 a.m. PST. And our next speaker will be Justin Azoff, and he will be presenting on Don't Be Sad. Make sure your input traffic is healthy. So please come again and join the webinar. We always look forward to great feedback, questions, or even just like participating in general would help us a lot to move with the project. So thanks again. I hope you guys have a wonderful day. And please, if you have any further questions regarding this webinar or in general, please don't hesitate to reach us out on our Zeek Slack channel, and we'll be more than happy to discuss anything further from there. So thanks again, everyone.